Hello students, this is the video clip. I think that this is the last topic in this chapter. Okay, the last topic is the topic about how to determine the resultance vector by calculation method. In this topic, I will separate the calculation method into 4 cases so that it's easier for you to understand. Okay, the first case is that when the vectors are acting 0 degree against each other. So what does it mean? It means that they are pointing to the same direction or they have the same direction. The angle between them is 0 degree. So how can we calculate? Actually, I think that it's not difficult. It's easy, much easier for you because I will suppose that the first vector is vector of force. Suppose we have force 5 Newton pull the object to the right, and we have another force 3 Newton pull the object to the right as well. Okay, so how much is the resultant force between these two? Okay, I think that most of you know that the answer is 8. Okay, it's 8 Newton. But why is it 8? Okay, we will prove by using drawing method because drawing method is the basic. Okay, it's the basic one that help us to determine how or why is the answer in this case is 8 Newton. Okay, first I will draw this vector which is 5 Newton and I put it here, right? And then I will connect my second vector or my second force, which is 3 Newton, and point to the right as well. We will draw by using head to tail. I will connect tail. I'm sorry, I need just only this. We have to connect tail of the second force or second vector here to the first vector, head of the first vector. So it will look like this one. Okay, our first vector is 5 Newton. It is vector of force, okay, plus 3 Newton. Our resultant will start from tail of the first vector, which is tail of 5 Newton, to head of last vector, which is 3 Newton force, okay? So this is our resultant. Our resultant will be the red one here, which is okay, actually it is 8 Newton, right? So this is why we know that it is 8 Newton. Okay, so I will summarize here that if we have the vectors that point to the same direction, parallel to each other, or the angle between them is 0 degree, so it means that we can add or sum the magnitude. Okay, we can sum the magnitude of those vectors, of any vectors that at an angle against each other with the angle 0 degree. Okay. Next, what if the angle between them is 180 degree or they point to the opposite direction? Okay. In this case, I will suppose the same. Suppose that this vector is force 5 Newton and there is another force with force 3 Newton acting on an object. Suppose these two forces are pulling the object, one pulling to the left, one pulling to the right. And how much is the resultant force between these two? Okay, I think that most of you can answer me automatically that the answer is 2 Newton. And which direction is it? It is point to the left. Why is that so? I will show you here by using the addition of vector by head to tail method. First, okay, again, I will do by drawing method. Then here I will copy force 5 Newton and move it here. And then this is 5 Newton vector. Then I will add this vector, 3 Newton vector. But I have to move its tail. Okay, its tail. Its tail must be at the same point as head of vector 5 Newton. Okay, and okay, I will draw. This is the head of 3 Newton vector. 3 Newton. What is our resultance? Our resultance starts from tail of the first vector. First vector that I draw is 5 Newton. N at head of 3 Newton vector. So this should be my resultant. Okay, this should be my resultant. I'm sorry. My resultant start from tail of 5 Newton. N at head of 3. Okay, the red vector is our resultant, which is subtraction between 5 and 3. So resultant is 2 Newton. And in which direction? Point to the left. So here we will conclude that if vectors at an angle 180 degrees against each other, okay, against each other, so we just subtract, we can subtract the magnitude. We can subtract the magnitude, okay, from each other, one from another. I will write as one from another. And the direction of the resultant will be, the direction is same as the longer one, okay, will be same as the bigger one or the longer one, the longer vector. Okay. Next case, the third case is the case that when the vectors acting an angle 90 degrees to each other. So it means that they are perpendicular to each other. For example, let's see in case one. Case one, suppose that we have two vectors. One is this direction, and the second one point to the left. And I will suppose that first vector that point to the left has a magnitude as a. Its magnitude equal to a. And this vector magnitude is b. How much is the resultance between these two vectors? Okay, because they are perpendicular to each other. So from the previous study, from drawing method, you know that if we have the vector look like this one, we can draw the resultants by using, because their tails are at the same point. So I will draw parallelogram from these two vectors. Okay, I will draw parallelogram from these two vectors. Okay, I suppose that this parallel to vector B and this parallel to vector A. Okay, and our resultants will be point to the opposite direction here. Oh, it is not straight. This is our resultants, right? Our resultants must start from tails of both vectors, point to opposite direction. And this is our resultants. And how much is it? It will be, actually, if you consider this right triangle, right? This is a right triangle. Okay, so we can say that because they parallel to each other, so it means that this one, I mean this one, its length must be the same as B. So I can write here as its magnitude as b. So now we have um, a right triangle. So this resultance vector will equal to we can determine the resultance or the magnitude of resultance by using Pythagoras theorem, right? So R here will equal to square root what? It will equal to square root A square plus B square. Okay, I don't need to review more because you study in mathematics already. Okay, so I will summarize here. Just said that whenever the vectors acting an angle 90 degrees to each other, so we can determine the resultance vector by using the Pythagoras theorem. Okay. Okay. So here's to here. I will suppose that suppose we have two vectors and they are acting an angle against each other with the angle of 90. I will let this the vector that point to upward, point to the north, its magnitude is 7. I will suppose that it is 7 meter, not 7 Newton, because it can be any kind of vectors quantity. Because you study already that displacement is a kind of vector quantity, so I can suppose that it is 7 meter. The unit is 7 meter. And next is 24. I will suppose that the next vector is its magnitude is 24 meter. And how much is the resultance? Here their tails are at the same point, so I will draw the parallelogram again. Okay, or it should be um, uh, I mean I draw the rectangle or parallelogram from these two vectors, and another line must be parallel to this one. Okay, my resultance will be this one. Okay, its magnitude will be, how about its magnitude? Its magnitude are here equal to square root 24 square plus 7 square or 25 meter. Okay, our result 10 is 25 meter. Okay, suppose that I the third example, we have two vectors. I will let this vector magnitude is 5 Newton and this is 3 Newton. Okay, and they at, at an angle 90 degree against each other. How much is the resultance? From this problem, you will see that they point, they connect by head to tail. So we don't need to use the parallelogram. We will draw the resultants by consider or using the head to tail. Our resultants must start from tail of the first and heading ending at the last vector here. So this is the direction and magnitude of our resultants, and it equal to our here equal to square root 5 square plus 3 square or square root 25 plus 9. 25 plus 9 is 34 Newton. Okay, next number 4, I mean case 4. Case 4, if we have vectors that acting an angle theta degree against each other. Okay, here I will let this vector has an the magnitude as a, okay, its magnitude as A. And this second vector magnitude equal to B. And this is the angle between these two vectors, okay? An angle, I call it as theta. It should be theta degree. Okay, how much is the resultance between these two? Actually, you can draw the resultance by using parallelogram, okay? So now I will copy vector B here. I will copy the another straight line that have the same has the same magnitude as vector B. Okay, and another one that same magnitude and direction as B, but I don't need to draw the arrowhead. Okay, I will move it here. So here we already got the parallelogram. And then our resultants will start from tail of both vectors to opposite direction here. This is our resultants. Our resultants here, how much is its magnitude? Um, their magnitude, so, sorry, the magnitude of this resultants vector will equal to, we can use this equation. I will tell you the equation. I will not prove for you because it's difficult for you all because you are all in M3. So I just would like you to remember the equation and use it. Okay, the magnitude of the resultants is a square plus b square plus 2ab cos theta. Okay, it means that square root of magnitude of vector A square plus magnitude of vector B square, and these terms are the multiplication between each term. It means that 2 multiply with magnitude of A multiply with magnitude of B and multiply with the value of cos theta. Theta is the angle between these two vectors. Okay, I will show you a little bit. I will list an example for you. Suppose that I have a vector. I will list the example similar to the previous case that we have 5 Newton and 3 Newton. Suppose this is vector 5 Newton, a force 5 Newton, and this is force 3 Newton. Suppose that the angle between them is 60. Okay, is 60. So we need to know how much is the angle between these two. So first I will draw parallelogram, and this is, okay, suppose they are parallel to each other. And this is our resultant. Wait, I'm sorry. Okay, this is how much is the magnitude of vector resultant of my resultant vector? R equal to square root what? Square root magnitude of first vector, which is 5 square plus 3 square plus 2 times 3. Okay, I let 5 as first vector. 2 times 5 times 3 times cos 60. Okay, cos 60. Okay, you know that the first term is 25 plus the second term 3 square is 9 plus 2 times 5 times 3 and cos 60. If you go back to the topic of trigonometry. You see in the table that I show you previous in the previous video. Cos 60 will equal to 1 half, okay? And 1 half here, we can cut this and this term, okay? So our result will be the summation of these terms. 25 plus 9 plus 5 times 3 is 15. Okay. How much is it? It is 34 plus 15 or 49. Okay. Or 7 Newton. Okay, that's all. Am I correct? Okay, yes. Because 25 plus 15 is 40. 40 plus 9, 49. Okay, finally we got 7 Newton. Okay, last topic, 6.7, vector components. This topic is very, very important for you, for those who are the students who study in physics, because vector components involved in almost chapters in physics. So you have to be able to determine the components of any vector. Okay. Suppose that we have vector A. Here, I will let this vector, its direction is in this direction, and its component, sorry, I mean its magnitude. Magnitude is this, the length of this one. Okay, I will let it as vector A, and also its magnitude equal to A as well. Okay, and suppose that it's at an angle, it's acting an angle against x-axis as theta degree. Its angle above x-axis is theta. Okay. For these vectors, we can determine or separate the component, determine the components of this vector into two directions. The first direction is on x-axis and the second direction is y-axis. Okay, the first axis, which is because its direction is northeast, right? A little bit to the north, but mostly to the east. So it means that this vector is composed of, or it's comes from two vectors combined to get to result this vector. Okay, so one component of this vector must be from the east. Okay, it must be from the east. It should be in this direction, and the other components must be from this direction. I mean the north direction. Okay, why? I will review this for you first. Suppose that we have two vectors. Suppose I have two vectors look like this one. Okay, this vector and this vector. When we add them all together, you know that the resultant should be, this is the resultant between these two vectors. Okay, this is the resultant. Or we can say that these two vectors combine to get this one. This is the result of these two vectors. Again, in the opposite way or vice versa. If we have one vector that has the direction look like this one, it means that this vector composed from these two vectors. Or we can call that these two vectors are component of this vector. Okay, next, here I draw this vector already, that we have original vector A at an angle theta degree above x-axis. And what are two components of this vector? Two components of this vector, one must point to the right as this original vector, and the other one must point to upward, and it must not over than this height. And also this one, I means the right vector, the component that point to the right or point to the east, must not over this point of the original vector. Okay, I will let this vector as component of A in x direction, and this one I will call it as component of A in y direction. And how much is the magnitude of these two vectors? Okay, before going to this one, may I draw the parallelogram again here? I will draw with using another color. This is my parallelogram. Okay. Let's consider this one. Okay, this one. How much is it magnitude? Okay, because this line parallel to vector ay, so this one length must equal to ay as well. Okay, and next we will consider this right triangle. Okay, we will determine or consider this this right triangle, and this side is called opposite. It's opposite side to the angle, and this side is called adjacent. Okay, let's go back to the previous study about trigonometry, that the ratio between opposite to hypotenuse, this is hypotenuse, okay, it is sine theta, right? Sine theta, sine of any angle equal to ratio of the length of the opposite side, which is ay, divided by hypotenuse. Hypotenuse here is a, so I will move a to multiply with sine theta. I will get ay equal to a sine theta. Okay, and as you study that cos of any angle, here we consider cos of this angle. Cos of this angle will equal to adjacent divided by hypotenuse, and it will equal to adjacent. The adjacent is the length of the vector ax, okay, ax divided by hypotenuse, which is a. Okay, and then now we will get ax equal to a cos theta. Okay, now I will summarize or write down here that the component ax here equal to this one, a cos theta. It is a cos theta. For ay equal to a sin theta. Okay, in summation or the conclusion that suppose that we have any vector that acting an angle against either x or y, the components of that vector which is close to the angle, it will equal to the original vector, magnitude of original vector multiplied with cos theta. And the vector that is far from the angle, okay, it's far from the angle that we are consider is this one, and this vector is far from the angle, it will equal to magnitude of original vector multiplied with sine theta. Okay, next to I will suppose the example and will do for you. Suppose that I have a vector here. Its magnitude is 25 Newton. Suppose it is a force and its angle, and I will write it here. I need to know, I haven't give you the angle yet. Suppose that this vector 25 Newton has an angle away from the positive x down to the southeast approximately, suppose its angle is 37 degrees. Okay, determine the component of this vector into x and y direction. Because this vector or this force is pointed to southeast, so its component, one component must point to the east and the second component must point to the south, like this one. Okay, so here I will draw this component and this is the second component. As I tell you that not draw over this limit. Okay, okay, how about this component? Because this component is close to the angle, so it will equal to original or magnitude of original vector multiplied with cos 37. Okay, and the downward component equal to 25 times sine 37. And how much is it? 25 multiplied with cos 37. Cos 37 is 4 over 5, or it equal to 5 times 4 or 20 Newton. And the downward component is 25 times 3 over 5. 5 multiplied with 5 divided 25 is 5 times 3 equal to 15 Newton. Okay, it means that this component of this vector, okay, I mean the x component equal to 20 Newton. Okay, its magnitude is 20 Newton. And the downward component, its magnitude is 15 Newton. Okay, I will let you do this 10 Newton. I will suppose that this is 10 Newton. And its magnitude is 60 degree, okay, away from the north to the west. Okay, the two component of this vector point to the north, and the second one must point to the west. Okay, because this component close to the angle, so it will equal to 10 times cos 60, and this one 10 times sine 60. Oh, I'm sorry. I have to move it down here. 10 multiplied with cos 60. Cos 60 is 1 over 2 or 5 Newton. Okay. And this is 10 sine 60. Sine 60 is square root 3 over 2 or 5 square root 3 Newton. Okay. I don't know how much is the time of this video clip, but I think that I will teach you the example. Okay. The example here. Number 1. Suppose we have force 15 Newton and 20 Newton exert to an object acting on an object. How much is the net force between these two forces when they acting an angle 0 degree, 30, 90, and 180 degree against each other? Okay, I will show you here that suppose that the angle between them is 0. Okay, the resultance will equal to summation of the magnitude between those two vectors. So it will be 25 plus 20 or 25. It must be 15 plus 20. And the result is 35 Newton. Okay. When the angle between them is 30 degrees, we just use the equation that I just gave you. Is square root what? Square root 15 square plus 20 square plus 2 times 15 times 20 and times cos 30. Okay, but we know that 15 square is 225 plus 20 square is 400 plus 2 times 15 2 times 15 is 30. 30 times 20 is 600. This is 600. Cos 30 is square root 3 over 2. Oh, really difficult for you. I will answer in terms of 625 plus 300 square root 3 Newton. Okay, I will not calculate more. I will answer as this term. Okay, and when they act an angle 90 degree, use Pythagoras theorem. Equal to square root 15 square plus 20 square or 25 Newton. Okay, last one. If an angle between them is 180, okay, we just subtract one from the other. Okay, so it should be 20 minus 15 or 5 Newton. And the angle must be point to the same direction as 20 Newton, but we don't know which direction between them. Okay, the last example. This example number 2, I think is a little bit difficult for you, but try to listen carefully. Now, number 2, we have 3 vectors, okay? Vector A, vector B, and vector C. We would like to calculate, the question is determine the resultance vector of the following vectors. Okay, it means that we have to add them all together in order to determine the resultance or summation between them. And how much is the magnitude of the resultance? I will indicate the magnitude of vector A first. Vector A is given as 5 units. Vector B, its unit is 10. Vector C, its unit or its magnitude is 15. Vector B, its magnitude is 10 unit. Okay, how can we do? First, you have to consider that how many vectors are there that are not on x-axis or y-axis. Here, A is on x-axis but point to the positive x, B point to the positive y, but C is only one vector that is not on all x, not on x and y axis. So we will determine component, the two components of any vectors that are not on x and y axis, because here only vector C, okay, only vector C that is not on x and y axis. So we will determine the component, its component. Okay, component of vector C, one must be downward and the other one must be right to the left. Okay, I will do quickly. I hope that you can remember and can understand the previous topic that I just taught you. Okay, about this component, it's away from the angle. This component is close to the angle. This component away from the angle, so it will equal to the original magnitude. Vector C, its magnitude is 15. Multiply with what? Multiply with sine of this angle. Okay, sine of 37. Okay, 15 times sine 305 or 9 unit. And this one, for this one, it's equal to original vector, magnitude of original vector, 15 multiplied with cos 37. But you know that 15 cos 37 is 4 over 5, or here is 12 unit. Okay, once we determine the components of any vectors, we can erase it because this vector is already represented by these two vectors. So now it looks like that we have four vectors that we have to add them all together. The first one is vector A plus vector B plus vector C x, C y, C negative y, C negative x, or I will redraw it, look like this one. We have vector A here, which is 5, and we have this vector. I will move this. I'm sorry, I will redraw again. This vector is 10 and plus another two vectors that are components of vector C. Okay, one is 12 point to the left. This is 12 unit, and the other component of vector C is downward with magnitude of 9. So next we will determine the summation or resultant between these two vectors that are on x-axis. Okay, the resultant should be 7 point to the left because 12 unit is greater than 5, so result the result between these two is 7. Okay, it is 7 unit. And the resultants between these two vectors, one point to the north, one point to the south, they are 180 degrees against each other, as you studied previously, that if the angle is 180 or the opposite direction, the resultant will be subtraction them from each other, and the direction is to the same as the bigger one, the larger the bigger. Here the bigger one is 10, because 10 is greater than 9. So resultant between these two should be 1. Okay, 1 to the point upward. So now our final resultant will be the result between these two vectors. Okay, I will draw parallelogram between these two, and then our resultant is this direction. This is our resultant. How much is it? It is our resultant. Final resultant of this problem is square root. Use Pythagoras theorem. Okay, final step. Use Pythagoras theorem, because you know that 1 and 7 here they are 90 degrees against each other. Okay, 1 square plus 7 square, or square root 50. Okay, or 5 square root 2, right? I will write as unit because we don't know what kind of these vectors. So I will put just unit. Okay. I think that I finished all the contents in chapter 1 already. And here will be your homework practice 1.5, but when will you have to submit? Just follow in the Google Classroom. And now I think that I will finish this video because this video clip is quite long. Okay, see you.